Hi, I'm Sam McArthur. I'm President of Walden Technology Partners, and I'm here on the campus of Worcester Polytechnic Institute, standing just outside Atwater, Kent's engineering building. And I'm here today with the founder of BlueRim Technology. We are here to meet the founders of Neuron Robotics. Neuron Robotics was a company that was founded by some Worcester Polytechnic Institute graduates, and they've developed a programmable interface for robots. Worcester Polytechnic Institute is actually going to be using the DyIO, which is the programmable interface, as part of their robotics classes for the upcoming year. So we're here to meet the founder, Kevin Harrington, and some of his team, take a look at the DyIO, and get some tips on assembling the hexapod, which the DyIO controls. So thanks for joining us today, and we'll step on inside and meet Kevin. Thanks.
Hello.
Hey, Kevin. Sam McArthur, President of Walden Technology Partners.
Kevin Harrington, President of Neuron Robotics.
And so we're here today to, number one, we're here to pick up our hexapod and our DyIO. But before we do that, would you mind just giving me a little background on Neuron Robotics?
Sure. So Neuron Robotics started as a company between Bob Resnick and myself. We had, at the end of 2008, the end of the school year in 2008, we had finished our senior projects.
Okay.
And both of us had robotic-based projects. We weren't working together, but what we realized sort of after these projects had failed miserably is that we had spent a lot of our time doing basically the same work. That upon reflecting, we realized, well, I did this to solve this problem. And he said, oh, well, I did this to solve that same problem.
Okay.
And we realized that there is this problem sitting there, which is how do you connect the real world to a computer and do so in a way that is easy to use, leverages the power of your computer, and can still interact with all those sort of real-world devices like servos and buttons and LEDs, and do so without that being the focus of the project.
Okay, so what'd you do?
So our response to that said, all right, let's make a generic device, something that solves all the problems that need to run on a high-speed, microcontroller style processor, which is what this device is, and say, all right, all of those things, let's make them available over a communication interface. And that communication interface is called the Bowler protocol. And that's sort of the basis.
Is that your protocol?
That is our protocol.
Okay.
We designed a protocol specifically for the use in robotics.
So what does Bowler stand for?
It actually stands for nothing.
Absolutely nothing. Okay, good.
So originally the name of the protocol was WASP, Wired Actuator Sensor Protocol, and we realized upon a little research that is very heavily copyrighted up one side, down the other. So as it turns out, we had a friend who was designing the logo, we asked to design a logo for us, and he designed the bowler hat logo. And we liked the logo, we liked the Neuron Robotics logo, and said, well, we need a new name for this protocol because our old name is taken. So, what about bowler?
And none of the hat manufacturers are coming after you, so that's good.
Different enough markets.
So good, okay. So you developed this module here, which is called
the DyIO, and it stands for Dynamic I/O Controller. DY and an I/O is capitalized.
Okay.
And you can see here, this device consists of this little module here. You plug it in over USB to your computer. Your application actually runs on your computer, as opposed to an application running on the device. And that's sort of the major difference between this device and most of the commercially available products in the same price range.
Now, does the DyIO work with just this hexapod thing, or does it work with other robots?
That is a fantastic question. This hexapod is actually meant to be a demonstration of just one feature of the DyIO.
Okay.
We in fact have a servo controller that runs on all 24 of the ports. But what makes it dynamic is that all 24 of those ports can be reconfigured into almost anything that a regular microcontroller port would be able to do. Digital ins, digital outs, analog in, and then we added a lot of software features. The servo controller has features that no other servo controller on the market has. We have stepper motors and encoders and PID controllers for linking devices together. All of the sort of low-level, high
So give me some idea of what your goal is for the company, because I know that WPI is going to be using this in classes, right? Is your goal education, to further education? Is your goal to be the controller for a bunch of robots in sort of manufacturing, which is where a lot of robots get used, or what?
So, we have short-term goals and long-term goals. The short-term goals are to get ourselves embedded into as many educational institutions as possible.
Okay, schools, listen. This is a program you can get your kids working soon.
And what's great about it from the perspective of the schools is that they can come in and basically buy a course in a box where they get not only our hardware devices and some pieces to assemble, kits, and so on and so forth, the Hexabot being the example of kit, but they also get a complete set of courseware material. So
you've already developed the courseware material?
In fact, WPI developed the courseware material and have given us access to redistribute it to any of our future customers. It's actually an open courseware model. So that includes labs, lectures, homeworks, and tests.
So we can actually go online after we bring this home. We can go online and we can start our bachelor's program in robotics.
That is the plan. As soon as we're able to get that course material up and posted on our site, we will be providing it and providing links to everything. Right now, we do it on a case-by-case basis, and any of the schools that want to interact with the courseware. We still are small enough to be flexible to provide very custom-tailored solutions to any schools. And as we build up a portfolio of these custom-tailored solutions, different schools would fall into different models. A big university would want a certain type of model, whereas a small high school would want a different model. So we're in the process of developing these custom-tailored models of what hardware kits, what purchasing plans. So WPI, as an example, buys all of the DyIOs at the beginning of the year, then charges a lab fee during the classes, and the students get to keep it at the end.
Okay.
So they get a robot and a controller at the end of their class that they have been, during the course of the class, trained on all the ins and outs of how to use it. Whereas a high school might want a more lower cost to the student program where they would buy the entire kit, they would hold on to it, and they would buy a warranty system through us, so that as the students destroy things, as students will destroy almost anything we put in their hands, that we as a company can provide some security for them so that they don't have to worry about their investments going away.
Great. All right. Well, let's stop there, and then what we'll do is we'll take out the Hexapod, the kit, and you can show us a few tips.
All right.
All right. So we'll be right back to you.